What we're going to do is think of this as two different graphs. So one of our graphs is this guy. So think of that as y equals, what the heck? So think of that as y equals the absolute value of x plus 2. And graph this. So this is what we did yesterday on your quiz, and now we're going to do this in the context of these problems. So if I had given you this yesterday, and if I had asked you to graph that, that is certainly something within the realm of what you would have had to be able to do yesterday on your quiz. So what we would have hopefully have known is we have this little 0 behind. So our point that we would have wanted to use would have been the point -2, 0. That's our vertex. So you're going to plot that point. And then the number in front of the absolute value bars is a 1. So that would mean from this point that we just plotted, the vertex, we're going to do a slope of a positive 1. So up 1, right 1, up 1, right 1. And make this kind of long. We're going to want all of these points for the way we're going to be solving this. And then we would also want a slope of a -1. And we talked about how we don't want to go down 1, right 1. We don't want to go down 1. This should be going up. This V should open upwards. So we're going to go up 1, left 1, up 1, left 1. And then this would give us that slope of a -1. Okay, there's Mr. Kubowitz. Good morning. Oh. Okay, yeah, no problem. So that is this side here. We just graphed the left-hand side of that equation. All right. Now I want to graph the right-hand side of this equation. So the right-hand side of this equation is just 5. So think of that as the equation y equals 5. So if you remember, when we just get y equals a number, not up and down, Cam, it is horizontal. Remember, we talked about how it's kind of the opposite of what you would think. The y-axis opens up or goes up and down, correct? But a line y equals 5 is the opposite. It's a horizontal line. So go to where the y value of 5 is. And basically when we have y equals 5, it just pretty much says no matter where I'm at, my y coordinate is always a 5. So if I just throw in some random dots there, they always have a y coordinate of 5. If I now just connect those to draw in that horizontal line, this is the line y equals 5. So the way we solve these through graphing is we now look at these two equations. So let me clean this up just a little bit. And we look to see where do they hit each other. So now look at those two graphs. I'm going to put big dots on where they intersect. So they intersect right here. They intersect right here. Notice we are trying to solve for x. That's when we solve an equation, we're trying to find an x coordinate. So go to this first dot right here. Isn't the x coordinate of this point, if I work my way down here, isn't that x coordinate a -7? So what that means is one of our solutions to this is a -7. So that's one answer to this absolute value equation. If I go over to this other big intersection dot, I'll make it even bigger. If I now walk my way down to this x coordinate, notice that this hits at the x value of 3. That is the other solution to this absolute value equation. Just like any equation you have solved in your life, you can always now test this, right? So now let's test this. So let's take this equation here. Absolute value of x plus 2 equals 5. Let's let x be, oops, that did not want that to happen. Let the x be a -7 at the beginning. So all I'm going to do, why is it not changing colors? Too fast. Let's try that. All right, so take this x is a -7, replace the x over there. So if I now get rid of this, if I do a -7, doesn't that give me a -5? But we know the absolute value of a -5 is a +5. Doesn't that make this now a true statement, that +5 equals a +5? So we know that's a solution. All right, if we took now the x value of 3 and we plug that in, so now let's plug in the x value of 3. This one's a little more obvious because isn't 3 plus 2 a 5? So now I get the absolute value of a +5, and then that would equal +5. So then that proves that these intersection points are one way we can actually figure out the solution to this equation. okay? The big thing to understand, notice how there's two answers here. A lot of your equations that you've solved in your life, it's usually one answer. The absolute value equation is going to have two answers a lot of the times. Not all the time, but in this case, we definitely do. All right, so now number two, same exact process. We're going to write two different equations. So this equation here, think of that as y equals the absolute value of x minus a 3. That's what we want to graph. So again, it's what we quizzed on yesterday. So hopefully we're all pretty efficient. That quiz did go reasonably well. If I ask you what point the vertex is at, notice how there is no x value in here with the x, no number with the x. So that means the x coordinate of our point is 0. And then we have that negative 3 on the back. So that means the vertex is 0, negative 3. So put a dot at 0, negative 3. We have a 1 in front of this, so that means our slopes are 1 and negative 1 again. So go up 1, right 1, up 1, right 1. And we want to make this long just so we can see where they hit each other. So we want this to be as accurate as possible. And then over here, we're going to go up 1, left 1 to create our V. All right. So that is the left-hand side graphed. The right-hand side is just a 7, so now we're going to graph the equation y equals 7. So all that means is I go to the y-axis at a positive 7, and we draw in a horizontal line. The solutions to this equation here is simply this intersection point right here, which is a positive 10. And yeah, this intersection, I didn't draw a very straight V with the black one, but it then should be a negative 10. So our two solutions are x equals 10 and, come on, could be, there we go. X equals the negative 10. Those are our two solutions. But again, I want you to show this because when we don't necessarily want to have to graph all of these because it takes some time. So what we're going to do is now take this equation, take this absolute value of x minus 3 set equal, I'm sorry, I wrote that wrong. And then minus the 3 equals a 7. If I test this now, if I take a positive 10 and I substitute it in here, isn't the absolute value of 10 10? And doesn't 10 minus 3 equal 7? Yeah, so that's one answer. Notice this is a negative 10. If I take a negative 10 and plug it in here, the absolute value of a negative 10 is also positive 10. Take away a 3, you're going to get a 7. All right? So now, with that, take a minute, graph number 3. I'll actually set it up here just to make sure we're understanding this. So this left-hand side, you're going to graph like you would have yesterday, this equation. The 2 times the absolute value of x minus a 1. And then on the right-hand side is the 8. You're going to graph the equation y equals 8. And all we're doing is looking to see where they hit each other. Okay? All right. So graph that real quick. Make sure we can do that. Write down your answers. You could then test your answers very easily. All right, so give me about 30 seconds, see if we get this. All right, let's see what we got. So if I wanted you to graph this one, what we would want to first do is identify what's our vertex, what's that shared point that we're going to start to count our slopes off from. So since right here we have x minus a 1, and then we don't have anything behind it, that means there's a 0 there. The point we wanted to plot is the point 1, 0. So that's hopefully where you put your vertex. Here's our number in front. That means our slopes are now a -2 and a +2. So from this point now, we should go up 2, right 1, up 2, right 1, up 2, right 1, and then up to left 1. All right, so that's the absolute value equation. Just again, same thing we would have done yesterday. Find your point, do your slopes. This is old. You just got to remember this is a horizontal line. So you go to the y-axis at 8, and draw in a horizontal line, and then pretty quickly, if we do that correctly, there's a solution, there's a solution. So this intersected at the x value of a -3. So that's one of our answers. And then this point of intersection right here is an x value of 5. So that is our other solution. All right. Simple enough, hopefully. All right. So now, number 4. Kind of the last one. Yeah, last one I'm going to have you do of these. Then we'll go to the next page. Graph that real quick and see what you think. So again, here are your two equations. Create some space here. So this equation on the left, you're going to treat that as y equals the absolute value of x minus 3 plus a 4. And then the equation on the right is just the line y equals a -5. Pretty good. We had almost 50 girls there. This was nice. And then we found out right as we were concluding, and we got bumped up a little bit, so we just got that shared out. Now we just gotta wait to see if we have any space so that we can schedule some preseason stuff. So, yeah, I'm happy overall. I mean, considering we're starting a little earlier, the season's a little longer. We don't go quite as much into the summer. We might have a postseason, which I doubt, but I mean, relative to what everybody else got, I wouldn't say they took care of us because we still don't have a normal season, but we got more than the other sports did. So, yeah. At the end of June. Right? Yeah. For sure. All right. So let's see what we got now. Our point here, if we look at this, we should be able to identify this point. This is working so good too until there we go. So here we have x minus a3 and then plus a4. So our point should be 3, 4. So that's where you should have plotted your point. So 3, 4. The slope is back to being a 1. We just have a 1 in front of this. So I'm going to go up 1, right 1, up 1, right 1 on the right side, and then up 1, left 1 on this side. So that's the left-hand side. When we go to graph that second one, we better know our horizontal lines. Now at this point, you're going to put a dot on -5. And you're going to draw in a horizontal line to that. So think about what we just said in those previous 3 questions. The answer to number 1 was the intersection of those 2 graphs. So those 2 intersections were our answers. Same with number 2. The intersections were our answers. Same in number 3, the intersections were our answers. So when we get down to number 4, notice how there are no intersections at all. So if the intersections are the answers to our questions and there are no intersections, just like regular linear equations that you've solved plenty of over the last few years, we can also have absolute value equations that have no solution. These notes don't show it. There's really 3 different things that could happen. You can get 2 solutions, and that's what happened in the first 3. You can get no solutions. We can also get 1 solution. So think about how we could get 1 solution. So don't necessarily change yours, just know this for future reference. If this is our situation here, it's a no solution. If I would have drawn in a line like I had done before, so let's say our line was right here, we would have had 2 solutions if that was the case. The way we could get 1 solution, that it is possible, is what if our other line went right through just the vertex? Notice how they only intersect that 1 time. So it is possible to also just get 1 solution of these. Most of the time you get 2, but you can get 0 and you can get 1. So just kind of keep that in mind for when we stop graphing these all the time, because efficiency-wise, we don't want to necessarily have to graph these all the time. So that's then kind of what we get into in this next page. So this says solve the absolute value equation algebraically. So algebraically means not graphing. We're going to do this like solving a regular equation. All right. So here's what we want to get out of this, and it's really shown best in this first one. I hope I left this up here. So when we solve this algebraically in terms of understanding why we're going to do what we want to do. So let me go back to this first problem. Starting to go on the fritz again. Too good to be true. Right? Like 1 or 2 days of stuff working like it's supposed to. Okay, there we go. All right, so with this one now, here's how we're going to do this algebraically. Think about what happened in this problem. I took the x plus 2, and I set that equal to 5. Well, if I took a negative 7 and I plugged it in right here, there's 2 numbers that can give me a 5. A negative 5, if I take the absolute value, will give me 5. That would work. So that's what the negative 7 does. But I could also take the absolute value of a positive 5 to get that to equal 5. All right? So there's a couple different numbers that are going to work in order for that to make this true. So kind of keep this in mind. I can take the absolute value. If I want it to equal 5, I can do the negative 5 or I can do that positive 5. So when we come down here to do this algebraically, in order to get our 2 solutions, one of our solutions, we're just going to basically say x minus a3 needs to equal 11. And you're going to solve that normally. It's about as easy as it can get. You're going to add 3 to both sides. Cancels. One of our answers is 14. Because if I want this to equal 11, aren't there 2 different numbers I can take the absolute value of? A positive 11 is 11. I'm sorry, 14. But yeah, positive 11 is 11. So that's why we took the left-hand side and set it equal to 11. But couldn't I also take the absolute value of a negative 11 and get that to equal an 11? So the way we're going to set up our second equation, if we can get this to equal a negative 11, so you're going to take your x minus a3, and we could also say that that's going to equal a negative 11. Add 3 to both sides, and we get a negative 8 for that answer. Think about now why these both work. If I take 14 and I substitute it in right here, doesn't 14 minus 3 give me the positive 11? And if I take the negative 8 and substitute it in right here, doesn't that one give me the negative 11? And then the absolute value of that is still going to give me that positive 11. All right, so those end up being our 2 solutions. If, let's not do that. We haven't really talked about set notation in quite some time. So we'll just leave it written as that. So if we were to graph those 2 equations, those are the 2 x coordinates where they're going to hit each other. Okay. Now, what you want to be careful of is something like this. Our goal with solving all of these equations, so So let me actually write this. This I would tell you to write in terms of our steps. What step number 1 always is, you want to isolate the absolute value bars. So what that simply means, I'll give you a minute to write that down. So what that means, we had already done that in number 1. So what I mean by absolute value bars, I'm going to highlight. So here's my absolute value bars. See how they're all by themselves on the left-hand side of that equation? That's what we need to have happen. If I look at number 2, however, here's my absolute value bars when I'm having highlighted. Those are not by themselves right now. That little pesky -6, we don't want that there. So if we're going to isolate this 2x plus a1, what we're going to do to make that work is we need to add that 6 over. That has to be your first step. Then you have your absolute value bars set equal to a 25. Then it's at that step that you're going to set up your 2 different equations. To get our 2 solutions, which if we have 2 solutions. So keep in mind now, what I need to have happen, I need to make the inside here either be a 25, because the absolute value of 25 will give me a 25, or I need to make the inside equal a -25, because if I take the absolute value of a -25, that would also give me 25. So the 2 equations that we are now setting up, one of them you just say, all right, what can I solve for x to make this equal 25? But then what we showed up above in those graphs, how could 2x plus a1 also give us a value of a -25? What x value would make that equal a -25? We solve both of those, so you're going to subtract 1 from both sides. So in that case, you get 2x equals 24. Divide each side by 2. That's one of our answers. So now take this 12 and plug it in. Doesn't 2 times 12 give you 24? And then 24 plus 1 is 25. And the absolute value of 25 is 25. Take away a 6, that will give you 19. If we now solve this one, add 1 to both sides. These will cancel. That now equals a -24. No, it doesn't. Yeah. Hold on. This painting's doing silly stuff over here. Give me a minute here. Try that again. We need to subtract 1 from both sides so that we can get rid of that positive 1. And then that should equal a -26. Divide by 2. -26 divided by 2 should be -13. That is then our second answer. All right. All right, so now number 3. Keep in mind that first step. So if we look at this right here, we need to get this by itself. Those are your absolute value bars. We need to get that by itself. So picture this as, so don't write this down right now, but think about if I gave you this equation. So don't write this on your paper. What in our first step here, I think we would all know, is to add 8 over so that we get 3x equals a 30. And then we would divide by 3 at the end. It's the same thing we're going to do to isolate these absolute value bars. The first thing we want to do is get rid of that -8 from the left-hand side. So we're going to add 8 to both sides. So cancels. We still have the 3. And then we have the absolute value bars that we're going to ultimately try to get isolated. So that now all equals a 30. We still don't have what I have highlighted by itself. So we now, since this is a product, we want to divide by 3. So that we now end up with x plus 2, that absolute value set equal to 10. few more steps to do it, but what we just did is we just went through and did step number 1 that I told you to write down, isolate the absolute value bar. So once you've done that, now you're going to set up your 2 different equations. So our 2 different equations should be what would make x plus 2 equal a positive 10, and what would make x plus 2 equal a negative 10. Each of those very simple to solve, I would hope. So these will cancel. So one answer is 8. Subtract our 2 here. And the other answer is negative 12. How many do I have here? 8. All right, let's do one more real quick. Here's our absolute value bars. That's what we want to get isolated. So to make that happen, the first thing we want to do is subtract 17. So these will cancel. We're getting negative 5, and then x minus a 4 equals a negative 10. Since that negative 5 is getting multiplied by your absolute value bars, we need to divide by the negative 5. So we're going to divide by negative 5. And then at this step, we now have the absolute values set equal to a positive 2. Set up your 2 equations real quick. Make sure we know how we're getting those. And then those should both be very quick and simple for you to solve once they are set up. Okay, so this first one, you just kind of solve normally, as if the absolute value bars weren't there, if it just equals a positive 2. And then think about it, like if I took 6 and I plug it in right here, doesn't 6 minus 4 equal a positive 2? The absolute value of a positive 2 is 2. The other thing we're concerned about is what would make x minus 4 give us a negative 2? You're still going to add 4 to both sides. And then now think about why this one would work. If I took 2, so if I took this x value of 2, and I substituted in right here, 2 minus 4 gives us a negative 2, but since I'm taking the absolute value of it, that's what's going to make this equal to the 2 that it's supposed to be. All right. All right. Let's see here. Yeah, I really wanted to get to 5. I'm going to spare you homework tonight. I want to make sure we do 5 together, and even 7, kind of the same thing. So with less than 2 minutes, you're going to be spared of any homework tonight. Bring this tomorrow. This is what we're going to pick up, and then maybe we'll get you started on the homework because the homework's a little lengthy anyway. So we'll get started on that, and then get started on the homework tomorrow. Okay? All right. So with that, we're good. We'll also go over the quiz tomorrow, so you'll be able to see what you got, hopefully, and then if you have any questions on that, you'll be able to ask those too. Okay? All right. We'll see you guys.
Bye, Mr. Finn. Have a good day.
Thank you, Nora. You too.